and then we'll talk about control of risk from stone dust containing high levels of crystalline silica. So just to set the scene, just to give some kind of background here. So crystalline silica is a very common compound that we find in a lot of minerals, a lot of rocks, a lot of natural substances. When these minerals are worked, when these are fabricated, we get airborne dust generated. That airborne dust will contain respirable crystalline silica, and that is the harmful airborne material that we are concerned about here. Overexposure, people in this room probably already know what I'm going to say here. Overexposure to respirable crystalline silica can cause a number of very serious, irreversible occupational health problems, including lung cancer, COPD, and silicosis, which is a fibrosis of the lung. Okay? Internationally, silicosis still remains an enormous problem. The ILO describes silicosis as one of the most important occupational health diseases in the world. And silicosis is normally a long latency disease. Typically, it would take 20, 25 years of exposure in an industrial situation for people to start to develop the first symptoms of silicosis. That's the kind of latency period that we associate with chronic silicosis. There is another much more aggressive form of the disease, which has a much shorter latency period, which is acute or accelerated silicosis, which is typically associated with very high exposures to respirable crystalline silica. Fortunately, we don't see that very often, but unfortunately, in the last 10 years or 50 years or so, we've seen a massive increase in accelerated silicosis in one particular industry sector, and that is in the manufacture of kitchen and worktop bathrooms. So what's changed? We've been making kitchen and worktop bathrooms for decades from natural stone products, and we've not seen this rash of accelerated silicosis. What's changed is the raw material. So in the last 15 years, there's been an almost exponential increase in the use of a new material for making kitchen and worktop bathrooms. It's called engineered stone, artificial stone. It's a man-made product. The problem is its crystalline silica content. So typically, we used to make kitchen worktops from natural stone, marble, 5% crystalline silica, maybe granite, which might contain as much as 40% crystalline silica, artificial stone. Certainly the first generation artificial stones, engineered stones, contain as much as 95% crystalline silica. So obviously the inherent risk of these materials is much, much higher than natural stone products, and that's why we've seen this unfortunate epidemic of acute and accelerated silicosis associated with this industry. Obviously, as the regulator in this country, HSE, are doing something about this, and there's a lot of activity going on within HSE to combat this. So the research project I'm talking about here is just one small part of HSE's intervention strategy. So we were tasked, my team was tasked with going out, so this is a workplace study I'm talking about. We went out into the real world, went out to companies that are fabricating kitchen and bathroom worktops using engineered stone. And we were tasked with monitoring the effectiveness of water suppression. So the generally held belief, and it is the right belief, is that the most effective way of controlling the dust when you're handling these materials and you're fabricating worktops from these high crystalline silica materials is to use water suppression, to run it under wet processes. There are alternatives such as local pulse ventilation. They will never be as effective in terms of controlling the dust. So we were tasked with going out and monitoring the effectiveness of water suppression, characterising the exposures associated with fabricating kitchen and bathroom worktops under water suppression. So I've already said this was a field study. We went out to 6 different sites. We recruited the companies. We did a little bit of talk about how to recruit companies. We worked very closely with the trade association to recruit these companies. The trade association were very helpful and very proactive in helping us to recruit these companies. We deliberately selected the sites to represent good exposure control practice. We know that what we have measured at these sites is not typical of what might be happening in other parts of the industry. What we were trying to understand here is how well can the risk be controlled if the right exposure controls are in place. And the right exposure controls are water suppression with control of the mist that's subsequently generated from the fabrication process. We did a lot of air monitoring. We focused really on air monitoring for respirable crystalline silica, obviously, but other things that are in these engineered stones have also been implicated in the toxicology of these materials. So we did also do air sampling for volatile organic compounds and also for metals too, and I'll touch very quickly on the results from that a bit later on. We took various bulk samples, and we obviously conducted a an occupational hygiene assessment of the controls in place, because the controls are the important thing that we're discussing here. So prior to engineered stone becoming a big thing, and prior to us unfortunately seeing these accelerated silicosis cases starting to occur, HSE had already got a suite of very comprehensive guidance on how to control crystalline silica exposures in stoneworking industry. I've just put an example on that slide there. All of our existing guidance focuses on using water suppression. There are mentions in there of situations where it might be acceptable to use local exhaust ventilation, but certainly our guidance, the thrust of our guidance, is on the implementation of water suppression and on control of the mist that's generated, because when these fabrication processes are run, you apply water to the process, you get a massive amount of wet mist coming off. That wet mist will contain respirable crystalline silica. You get a huge range of particle sizes coming off. A lot of it's very fine particles. It will travel a very long way from the emission source, and it does contain respirable crystalline silica. So water suppression on its own is not enough. You have to control the mist that's generated from the process. Just a general overview of the sites we visited. These were all SMEs. The biggest site we went to, we've got 35 workers employed in fabrication, and that is typical in terms of business size. That is typical of this industry. There aren't big, huge companies employing thousands of people. The industry is almost exclusively made up of SMEs. We obviously targeted our visits at companies that were predominantly using high crystalline silica stones. That was the target of this. So we went through a screening questionnaire with these companies before we actually agreed to take them on board for the project, to make sure that they were the right kind of company. The essential bathroom, kitchen, worktop manufacturing process is the same at all sites. They take a great big slab of engineered stone, it's cut with automated bridge saws to the right size. They use a variety of processing machinery, generally big machines like water jet cutters and CNC routers to then cut out holes and sink taps and things like that in the surface. Most of these big machines are enclosed. They've got screens around on all four sides. But crucially, I think it's important to know these enclosures are only a couple of metres high and they don't have a lid on. So we're talking about respirable particulate here, and that will escape over the top of a 2 metre high enclosure, and I'll talk about that a bit further. But I think critically also, every company that's making these worktops, a significant proportion of the workforce are involved in hand finishing tasks. Probably 25–30% of the workers in any fabrication company will be on the hand finishing area, okay? And that is a higher risk activity. That's not so automated. They're using hand tools, handheld power tools to do that. They're in a much closer proximity to the emission source, and hand polishing, wet water suppressed hand polishing generates a huge amount of wet mist. So these are just the initial findings, a very basic initial assessment of the data. We've generated a mass of data from this project, and I can't talk about it all today. I know there's a lot of information on that slide, so I'll just try and focus on the main points here. Okay, then. So in the UK, we have a workplace exposure limit for RCS of 0.1 milligrams per cubic metre, which is the same as most of the rest of Europe. 1 or 2 member states have gone lower than 0.1, but our limit is the same as most of the rest of Europe. I've tried to separate the exposures up by different job, by different parts of the fabrication process. Okay, I've got a job group in there called stonemason. Okay, they are not wet processors. They are people doing bespoke, highly skilled masonry work, making very particular products. Okay, our focus wasn't to go out and measure the exposure associated with dry processing, but we took the opportunity while we were there, if they've got any dry processing on site, to get some measurements. You will see that the exposures for that particular job category are much higher than the other exposures that we measured. Even with local exhaust ventilation in place, the exposures associated with dry work are much higher. To some extent, they'll be mitigated by the use of respirators, because companies that are doing this kind of work will not, hopefully not have workers doing it without at least respiratory protective equipment. But that just illustrates the kind of exposures associated with dry processing. Contrast that with the exposures that we see associated with wet processing, which are orders of magnitude lower than that. we recognise that the well is probably not a safe level of exposure, but I think it's important to note that if you look at the median exposures there, the highest group of workers, the highest median exposure for any group is only 33% of the current well in this country, and that unsurprisingly is for the hand finishers, the hand polishers. We kind of expected that they would be, and these data fit with other published data. The number of studies have been published looking at this exposure associated with wet processing in the last couple of years, and we're all coming out with very similar conclusions. The exposures are in this kind of ballpark. Okay? I'm going to skip through that slide. In terms of the other things that we're measuring in the air, I've not got time to go into these in great detail. For the respirable crystalline silica, we focused on personal monitoring because we're interested in worker exposure. That is the real test of how well the controls are working. But we were interested in these other things as well, metals and VOCs. Obviously, we can't fit workers up with multiple samplers, 3, 4, 5 samples, because it burdens them down. So some of our data for the other contaminants is from static sampling, but nevertheless, I think it gives us a very good feel for the level of risk associated, or coming from these other things that might be present in the storms. For metals, we've got a lot of results for both inhalable and respirable metals in the air, and I would say that they indicate very, very low exposure potential. They're well below, orders of magnitude below any exposure limits that exist. I don't think metals are going to be part of the problem here in terms of this. VOCs, volatile organic compounds, I would say almost the same as metals. However, we have picked up very few elevated results. I've got to be honest, we can't explain them at the moment. They're a little bit inconsistent. We've not found them consistently at different sites. And there's more work going on at the lab at the moment to try and understand where these elevated VOC exposures might be coming from. Because the organic material is part of the resin that's used. I should have said that at the beginning, sorry. These engineered stones, they're not 100% mineral. There'll be a proportion of resin, organic resin in there to bind things together. And obviously, if you're going to generate a dust, then a proportion of that dust will contain these organic resins as well as the mineral dust. In terms of the control and how could controls be improved if we want to get these exposures down even lower? Well, certainly on the big machines, I've already said, although they're screened on all 4 sides, there's no lid on the enclosures, and you can see if you shine a dust lamp, a tyndall beam across the top of the enclosure, you can see a lot of particulate, fine particulate, escaping from that enclosure. And because it's respirable particulate, it will travel a long way. Once it gets out of that enclosure into the air, it will never land, it will never fall to the floor. The only way that it's going to leave is when it eventually gets out of the factory via natural ventilation. Okay? In which case it's important then to put better enclosure around the actual emission source, around the saw blade or around the router bit. And there's ample opportunity on these big machines, I think, with some very simple steps, things like plastic, flexible curtains and baffles around the blade to significantly reduce the emissions from the tool, from the machinery. Okay? I'll talk about water cleanliness now, and I'll talk about it again a little bit more further on, because all of these water suppressed processes are on a recirculating water system. These machines consume vast amounts of water. It's not practical to supply these machines with clean water from the mains. The consumption and the amount of wastewater that it would generate is enormous. So they're recirculating all this water around and round. And potentially every time it goes round, it's picking up a little bit more silica contamination, and then it's aerosolized again the next time it comes down. So it's important to keep this water clean, and that's already mentioned in HSE's guidance. You know, it's not just enough to have the water suppression and to control this, but keep the water as clean as you possibly can, because it could be that is a very, very significant deterrent to the actual exposure in these situations. When it comes to the hand polishing, which I've already said, we've got the higher exposures here. We saw varying strategies in place at these different companies to try to control them. Some of them were doing very little other than giving the workers respirators to wear, which is obviously the very bottom end of the hierarchy of control. We expect to see better than that. We saw water wall booths in use at some sites. Some of these water bag booths are venting externally to the external environment. Some of them are recirculating back into the workroom. Obviously, if companies are using these circulating LEV systems, then they need to have some confidence that that's actually filtering the contaminant from the air before it discharges it back into the workroom. And again, there's work going on at the moment up at the labs to try and understand the filtration efficacy of these water-backed booths. Touching very briefly on the other findings, where we have workers exposed to prescribed crystalline silica, we expect to see health surveillance programs in place. HSC have got very clear guidance on what health surveillance should look like for workers exposed to spiral crystalline silica, and that does include the use of chest x-rays. You will not detect silicosis through spirometry. You need chest x-rays, or at least chest x-rays and possibly CT scans to detect silicosis. Even at these good performers, the use of x-ray, or the inclusion of x-rays in their health surveillance programs was very unusual. Only one of the sites that we visited were actually doing chest x-rays. Okay. Unsurprisingly and disappointingly, again, and I've done a lot of work in multiple different industries, where they're relying on respiratory protective equipment, it's not being used properly, it's not being used consistently, they've not identified by risk assessment the worker groups that need it, they're not giving the workers the right equipment, they're not training the workers to use it properly. It was just underlines time and again why RPE sits at the very, very bottom of the hierarchy of control. It's important and it's necessary, but it cannot be the only control that's in place. And I think to give some good news and some balance, there's a very clear trend that the manufacturers of these engineered stone products have obviously received a very strong message from the market, not just from the UK. I mean, these things are banned in certain jurisdictions, they've been banned in Australia, and I think that's had a very positive knock-on effect, that they are reformulating these products to contain much less crystalline silica. There's a very strong trend in the UK towards these lower crystalline silica alternatives. That's great, it reduces the risk, but it does not remove the risk, and there's still a need to control the mist that's generated when you're processing these lower crystalline silica materials. Coming back to the processed water, I've said it's always recycled. We saw a lot of variation at these different sites as to how they keep their water clean, and some of them did very little to keep it clean. Most of them would do things like adding flocculants and coagulants to try to get the particles to clump together and to fall out of the water by sedimentation. Occasionally you see filters in place, you see various filtration arrangements that are associated with specific machines. But I think the way that the water is kept clean and the need to keep the water clean is probably not as well understood within the industry as it needs to be. And obviously, well maybe not obviously, but if you've got a system that contains a lot of water and you recirculate it round and round, and it's potentially going to become stagnant if it stands still at the weekend, if you switch the floor for the weekend, if you get the right temperatures anywhere above 20 degrees centigrade, and then you aerosolise the water in the process, then you've got risks over and above the spiral crystalline silica. You've got things like Legionella, bugs are going to grow in that water, and you re-aerosolise it. So again, that's another risk for these companies to consider, which I don't think is currently being adequately considered in the industry. We don't really know the extent of the Legionella risk. We know that in theory the risk exists because you've got the right conditions for the organism to grow and reproduce in the water. We're not aware of any cases of Legionella in the industry, but that doesn't mean that it's not happening. So again, there's more research going on up at the lab to look at this Legionella risk. So just to wrap up, to conclude, I think I would say from the companies we visited here, recognising that these are biased toward the best end of the industry, it's possible to manufacture kitchen and bathroom worktops from high crystalline silica stone using wet methods at all stages. I don't think there's any need for any dry fabrication methods at all. Machinery exists, equipment exists, tooling exists to allow this process to be done completely under water suppression. Okay? It's important to remember that that is not enough on its own. You've got to control the mist that's being generated. You need to employ the well understood, hopefully, hierarchy of control. So reduce the amount of RCS in the mist, keep the water as clean as possible, reduce the mist generation, things like LED systems. And RPE only comes in when we talk about controlling the residual risk. So you need to do everything above RPE in that list before you fall back on relying on RPE, because it is such an unreliable control method. So I think just re-emphasise that water suppression is important, very important. It is well accepted that it's the most effective method of controlling the risk. I would say that the risks associated with relying on LEV are so great that we really should be discouraging the use of LEV as an alternative. Water suppression is has got to be part of the control solution. But control's complex, and you've got to remember to control this mist because it does contain spiral crystalline silica, and that does represent a hazard in and of itself. Okay. It's important to remember that the exposures that I've presented here reflect good control practice. You're not going to see accelerated silicosis in these fractures. You know, I'm not saying that there is no risk at these levels of exposure. There will be a risk of chronic silicosis at these levels, but the accelerated silicosis is almost certainly associated with dry processing and zero exposure control. So we have to remember that these results reflect good practice. These tell you what the level of risk is if the process is done right. Okay. And I think the few measurements that we got for dry cutting just emphasise to us what we kind of already knew, that even a small amount of dry cutting, 10 minutes a day without the right controls in place, can put you over the 8-hour time weighted average workplace exposure. It really needs to be sort of discouraged in the strongest possible terms. So I've already said there's ongoing research at the labs looking at the VOC exposures because we can't fully explain some of the results we've got. We're doing some work to look at the impact of contaminated water and exposures because water suppression is much more widely used than the kitchen worktop manufacture sector. It's used right across the stone sector, it's used right across the construction sector, and I don't think we understand enough about water suppression as a control. We understand a lot about local exhaust ventilation and LEV systems. There's been a huge amount of research done. If you do literature searches on water suppression, you'll find very little information out there as to how to make it work effectively, and also the Legionella risk. So, thank you very much. And I'm happy to answer any questions.